Hi everyone, I am Fajri, a PhD candidate from School of Computing and Information System at the University of Melbourne. This is a joint research with Jehan Lau and Timothy Baldwin. The title of this paper, IndoBERTweet, a pre-trained language model for Indonesian Twitter with effective domain-specific vocabulary initialization. Although transformer-based pre-trained language models have been a breakthrough in NLP, obtaining high-quality contextualized representation for specific domains such as legal, social media, and medicine is still challenging. Pre-training from scratch is expensive, and as an alternative, Guru Rangan et al. 2020 said, don't stop pre-training, which means to continue the pre-training in the domain-specific corpus. However, the main drawback is that domain-specific words that are not in the pre-trained vocabulary are often tokenized poorly. For instance, in BioBERT, immunoglobulin is tokenized to many subwords, even though it is a common term in biology. Domain-specific BERT model in previous works were pre-trained in different ways. One is pre-trained from scratch, and the other one is based on domain adaptive pre-training. Although domain adaptive pre-training is effective, it's still not as good as training from scratch, as has been shown in legal BERT experiments. In this work, we focus on efficient model adaptation under vocabulary mismatch, hoping the domain adaptive pre-training to be as good as pre-training from scratch. But before we jump into that, why our experiment is conducted based on Indonesian Twitter? So there are two primary reasons. First, Indonesia itself is the fifth most populous nation, but underrepresented in NLP. And second, Twitter is often used to support various aspects of Indonesian, such as politics, business, and etc. And previous works have used traditional approaches such as n-gram language models or recurrent neural network. Therefore, in this work, we released IndoBERTweet, the first large-scale pre-trained Indonesian language model for social media data. We crawl Indonesian tweets over a one-year period using the official Twitter API with 60 keywords covering diverse topics. In total, we used 409 million words token, which are 2 times that of IndoBERT pre-training data. As pre-processing step, we follow the same step with English BERTweet, where we perform lowercasing, converting user mentions and URLs into special tokens, and finally, we transform Unicode emoticons into text. For model architecture, we follow BERT-based uncase or IndoBERT model. To obtain IndoBERTweet, we apply domain adaptive pre-training on the domain general IndoBERT by Koto et al. 2020, which is trained over Indonesian Wikipedia, news articles, and Indonesian web corpus. Both models have roughly 32K size vocabularies with overlapping tokens are 54%. Our goal in this domain adaptive retraining is to fully replace IndoBERT's vocabulary with IndoBERTweet vocabulary. To achieve this goal, we investigate 4 different ways to initialize new types. First, by simply random initialization based on uniform distribution, and second, based on normal distribution, where the mean and standard deviation are learned based on IndoBERT embedding. Third, we apply linear projection strategy by Porner et al. 2020. We first train 300-dimensional fast text embeddings over the tokenized Indonesian Twitter corpus. We use the shared types to train a linear transformation from fast text embedding to IndoBERT embedding. And lastly, we use IndoBERT tokenizer to tokenize the new type and then simply perform averaging over subword embedding to produce the new type embedding. To benchmark the proposed methods, we first pre-train IndoBERTweet from scratch. And secondly, we simply perform DAPT or domain adaptive pre-training for 200K steps. And the remaining 4 models are based on domain adaptive pre-training with different vocabulary adaptation strategies. We perform fine-tuning over these models with and without future pre-training. For other baselines, we also report the performance over 2 IndoBERT models, MalayBERT and MBERT, that potentially contains information or signals of Indonesian language. To evaluate the pre-trained models, we use 7 Indonesian Twitter datasets as summarized in this table. This includes sentiment analysis, emotion classification, head speech detection, and name entity recognition. Now let's take a look at the results. First, in terms of baseline, MalayBERT is a better model for Indonesian than MBERT. It is consistent with Koto et al. 2020. So here, IndoBERT models also perform better than 2 previous models, with both IndoBERT perform the same in terms of average performance. IndoBERTweet, which is trained from scratch for 1 million steps, results in almost 3% absolute improvement, which is consistent with previous findings that off-the-shelf domain general pre-trained model are suboptimal for domain-specific tasks. Next, we pre-train IndoBERT without vocabulary adaptation for 200 case steps and find that the results are slightly lower than IndoBERTweet. When we replace the vocabulary based on the aforementioned strategies, the results drop overall relative to the original model, with the embedding averaging method yielding the smallest overall gap. However, we see a strong improvement for all initialization methods after we pre-train for 200 case steps in the target domain. In fact, outperforming the domain-specific IndoBERTweet when trained for 1 million steps from scratch. These findings reveal that we can adapt an off-the-shelf pre-trained model very efficiently or 5 times faster than training from scratch with better average performance. In conclusions, there are two primary contributions of this work. First, we present the first large-scale pre-trained language model for Indonesian Twitter. And second, we explore domain adaptive pre-training with domain-specific vocabulary adaptation using several strategies with averaging of subword embeddings from the original model achieve the best average performance across 7 tasks. Thank you for your attention, and we'll release the code in this GitHub URL. And lastly, please check the paper for the other technical details. Thank you.